Okay, so now that we know about a 5-number summary of ordered data, we can talk about the interquartile range. That's going to be our measure of spread, our measure of variability for ordered data. So all that the interquartile range is, it's the distance between the lower quartile and the upper quartile. So it's just take your upper quartile, subtract your lower quartile, and that gives you your interquartile range. And for this example, we have an upper quartile of 17, a lower quartile of 10. So the interquartile range is 7. The distance from the upper quartile to the lower quartile is 7. Now, when we're talking about extreme data points, just like we did with the mean absolute deviation, when we were talking about data in terms of means rather than ordered data and using the median, we need to determine when is a point too extreme to be considered usual. And it can be shown statistically a good choice is 1.5 IQRs past either the upper quartile, so 1.5 IQRs this way, and I'll do this a little more accurately in a second, or 1.5 IQRs in the other direction, less than the lower quartile. So let's figure these. We can call them fences, an upper and lower fence. So let's figure out our upper fence for the example that we have. So it's going to be the upper quartile, and it's going to be 1.5 IQRs. And our IQR we worked out, maybe I'll actually write this in terms of the formula first. We'll write this as the upper quartile. So it's the upper quartile 17, and it's 1.5 IQRs, which is 7 in this case, bigger than 17. So if we work that out, that's 17 plus 1.5 times 7, you can check, is 10.5. So this is 27.5. So we're going to say that if we had a data point past 27.5, then we would call it an outlier. Let's do our lower fence now. So that was our upper fence. Our lower fence, so it's going to be the lower quartile minus 1.5 IQRs. Remember, we're going 1.5 IQRs past the upper or lower quartile. So less than the lower quartile and more than the upper quartile. So if we work this out, our lower quartile is 10, and 1.5 times 7, so that's 10 minus 10.5, so that's negative 0.5. So we can say that at any point, if we had one, past negative 0.5, anything out here are outliers. They're too extreme. So in that case, we would say that they're too extreme for us to consider them as usual values. In this example, though, we don't have any outliers because we know the smallest data point and the largest data point are within our fences. Everything in here is considered usual data. This is usual, and everything outside our fences is unusual. And just a very quick note here. That note is as follows. If a data point is directly on a fence. You just have to come up with some rule, but the usual rule for us will be then it is not an outlier. Getting a little messy there. I apologize for that. Let me box that off just a little bit better. So we don't have a data point outside our fences, so we don't have any outliers in this data set, however big this data set is. Remember, this data set doesn't have 5 elements. Remember, this is the 5-number summary of the data set. And remember, between each of these 5 numbers, there is roughly 25% of the data. And we'll talk about what that looks like as a histogram a little bit later, because there's a nice relationship between ordered data and 5-number summaries and box plots, which we'll talk about next, and histograms. All right, so let's talk about a graph for ordered data called a box plot. In some weird sense, it's a very crude version of a histogram that we talked about in a previous video, where we're kind of only having 4 bins for our data. And instead of having each bin the same width, we say that each bin contains the same amount of data, and that amount of data is, of course, 25%. So the idea, it's going to look something like this. I'll just sketch one, and then we'll do an example on the next slide. So box plots look something like, say, this, where this value here is the lower quartile, then we have our median, then we have our upper quartile. Then we have, well, this side is easy. We don't have any outliers to the left, so the min is just going to be where the box plot ends. But on the right-hand side, we do indeed have an outlier. We mark it with a star. Any outliers, we mark with stars. And then, so that is the max, but this point here is the largest non-outlier. So this is just a typical example. We'll do a few to see how this works in practice. So I'll give you a data set and we'll go from there. So a quick read of the steps here. So the first thing you want to do is you want to create a 5-number summary of your data. We talked about how to do that in a previous video. Determine if there are any outliers in our data. We talked about that on the previous slide, how to determine if there are any outliers. So we're going to have to calculate the interquartile range and then find if any points are 1.5 interquartile ranges more extreme than the upper and lower quartiles. If there are any outliers, put little stars on the graph that represent them. Then we're going to draw straight lines at the lower quartile, median, and upper quartile, and the largest and smallest non-outlier values. And then we're going to put a box around the middle 50% of our data and whiskers from the lower quartile to the minimum and the upper quartile to the maximum. Or if it's not the minimum and maximum, it's the largest and smallest non-outlier values. So that's how this works. Okay, so let's do an example. So let's draw a box plot of the following data set. So let's say it's this guy here, and I already put it in order for us. So the first thing we need to do is we need to calculate the 5-number summary. So let's go ahead and do that. So let's find the median first. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 data points. So we need the one in the middle, so the 7th. 13 plus 1 divided by 2 is 7. So 1, 2, 3, 4, 5, 6, 7. So that is our median. Okay. So now that we have the median, it is an actual data point. It's not the average of 2 data points. So we're going to exclude that from the 2 halves that we just built. And we need the median of these guys. And that'll give us our upper quartile and lower quartile. Okay. So we have 1, 2, 3, 4, 5, 6 data points on either side. So we need the average of the 3rd and the 4th here to give us our lower quartile. So the average of 8 and 9 is, of course, 8.5. So that is our lower quartile. And we need the average of the 3rd and 4th data point in the upper half of the data. So the average of 19 and 22 is 20.5. And that is our upper quartile. Okay, and we have the max and the min here. No problem. Min, max. Okay, so let's determine if there are any outliers. So we did step 1. Step 2 is determine if there are any outliers, because we need to put stars on our plot where there are outliers. So we need the interquartile range. So the interquartile range for this data is going to be the upper quartile 20.5 minus the lower quartile 8.5. So that is 20.5 minus 8.5 is 12. So our interquartile range is 12. Now our upper fence is going to be anything 1.5 IQRs bigger than the upper quartile. So it's going to be our upper quartile is 20.5 and then plus 1.5 IQRs. IQR in this case is 12. So it's the upper quartile plus 1.5 IQRs. Remember, 1.5 IQRs past the quartiles. That's our extreme values. So we work this out. This is 20.5 plus, well, 1.5 times 12 is 18. So this is 20.5 plus 18. So this is 38.5. And here, our lower fence. Same idea, but instead of using the upper quartile, we use the lower quartile. So it's going to be 8.5 minus 1.5 times 12. So that's 8.5 minus 18, which is, of course, negative 9.5. Okay, great. So now we can determine if we have any outliers. And we do. We have one outlier above. So this guy here, because it's bigger than 38.5, it's an outlier. So here's one outlier. It's too big. And below, do we have any data points that are below negative 9.5? We do not. Our minimum data point is 0, so we don't have any lower outliers. We only have the one upper outlier. Okay, so we're good to go. This is our smallest non-outlier data point, 0. Here it is here. I'll highlight it in yellow. And our largest non-outlier data point is 30. So let's go ahead and make our box plot. I'm just going to sketch it on a number line, and I'm sketching it horizontally. You don't need to sketch it horizontally. You can sketch it vertically if you like. In fact, that is a totally fine way to have box plots. Maybe we'll do the next one vertically. Okay, so let's put in our, well, let's put a scale in first. So this will be 0, 10, this will be 20, this will be 30, this will be 40, and we need a little bit more. So we have an outlier at 44, which is about here. So we put a star at 44 because it's an outlier. Okay, and now we're going to draw vertical, in this case, vertical lines that go with the upper quartile, the lower quartile, the median, and the largest and smallest non-outlier data point. So we have a vertical line at 0, we have a vertical line at 8.5, we have a vertical line at 13, we have a vertical line at 20.5, and we have a vertical line at 30. So let me kind of mark these. So this is 8.5, this is 13, this is 20.5, and that is, of course, 30, and I guess I should do this one too. This is at 0. Okay, so we put vertical lines at each of those places. Now we draw a box to go around the middle 50% of our data, and whiskers from each upper and lower quartile to the appropriate largest or smallest non-outlier point. So there we go. And in each case, we have, of course, roughly 25% of our data in each quadrant. So hopefully that makes sense to you. Let's do one more example, and we'll go from there.